Hi everybody, so today we're looking at the octane number and the different processes that can affect the octane number and what I've got to say about this. Oh, just that, look, at this stage now this question comes up on a yearly basis. Like, without fail, there'll be a question 6. It'll appear somewhere. Now, it might not appear every year as such for the processes, but octane number generally does appear most of the years, looking back. So look, we'll just get started there. Starting off with 2019 actually is what we'll start off with there. And you can see here straight off, I'm not going to be doing the full questions. I'm only going to be doing parts of it, and we'll be going from there. Now, 2019 question 6, and all of these are actually question 6s as I just stated. So this is asking you, what term is used to describe compounds like A, B, and C that have the same molecular formula but a different structural formula? So what term is used to describe those over there? Now, this comes back to your definitions that you just have to learn off. There's no getting around these. Okay, you have to say the word a structural isomer. So they're structural isomers, that's what they are. Okay, where they have a different structural formula but the same molecular formula. That, i.e., they have the same type of carbon atoms, type of hydrogen atoms there. Okay, just rearranged differently. So part 2. Why do A, B, and C separate in the same fraction in the distillation of crude oil? Now, students get bogged down with this all the time. Okay, especially when they're trying to learn off, and it's hard, to be fair now, learning off fractional distillation there and trying to learn off all the different components. Okay, so that is tricky enough, I know that. But if they all separate out at the same fraction, okay, that must mean that A, B, and C have a very similar or identical molecular masses. So they have similar or identical, whichever way you want to call it, molecular masses. So if they have similar or identical molecular masses, that must mean that they have the same boiling point. Remember, the more carbon atoms present, the higher the boiling point. That's why at the very lower members of the fractional distillation, they could be very high in the number of carbons, whereas the refinery gases, they all have a low amount of carbon atoms. Okay, so similar or identical molecular masses, okay, that means they must have the same boiling point. Okay, something along those lines. You only need to say one of those actually. You could have said both, it's up to yourself. Okay, so part 3. Explain which of A, B, or C is most likely to auto-ignite in a petrol engine. Okay, so we don't want auto-ignition to happen. We'd rather that not happen, in fact. Okay, so we often try to increase the octane number as much as possible to prevent auto-ignition. So from that idea, I suppose you can imagine there that the one there with the lowest octane number would be the one that will cause, most likely to cause auto-ignition. In that case, A must be our answer. If we're looking at it here, A has the longest carbon chain here. Okay, the longest carbon chain, or you could say it is the least branched. You can see there's methyl groups in B and C. Okay, and by adding in methyl groups, you're making it, what's the word I'm looking for? You're making it branched, and therefore you're increasing the octane number. So the answer is A, because it has, now don't say it has a long carbon chain, say it has the longest carbon chain. There's a difference. Carbon chain, and I'm also going to make reference to it is the least branch. IV. Give the systematic IUPAC names for A, B, and C. So you have to name A, B, and C. Okay, so look, we'll start off with A. So count out the number of carbons in the longest continuous chain, and you can see here there's only one chain, there's no methyl groups, so this should be easy enough. 1, 2, 3, 4, 5, there's no double bonds present, so therefore A equals pentane. What about B? Now, again, you count out the longest continuous chain, and you can count it out from both sides to be sure. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4, and again, if you count it from the end, 1, 2, 3, 4, 1, 2, 3, 4, no matter what, 4 is going to be the longest continuous chain. Now, you must now put in where the methyl group is present. So all you do here is, again, you want to attach the methyl group. We're going to say this is the methyl group here because it's the easiest to look at. The lowest number possible. So we count from left to right. It becomes 1, 2, 3, 4. So our answer for B is going to be 2 methyl, because 2 indicating where the methyl group is found. Okay, 2 methyl, and again the longest continuous chain was a 4. 1, 2, 3, 4. So we can see here. So 2 methyl butane is our answer. And now we go on to C. Okay, so C looks obviously a little bit more trickier to name, but the process is still the same. Count out the longest continuous chain. 1, 2, 3, 1, 2, 3. No matter what way we count it, it'll always be 3 being the longest. Okay. Next, write in the numbers here. So I'm just going to do this here. 1, 2, 3. It doesn't matter whether you count from left to right here or right to left, or you could actually go vertically too if you wanted to. You could do it this way: 1, 2, 3. Okay, or 1, 2, 3. It doesn't matter really in this case. However, sometimes it's just easier to stick to the norm and count from left to right. So we can see on the second carbon here that there are 2 methyl groups. So that means there's going to be a dimethyl. So if we're naming it, it's going to be 2,2, because there's 2 of them there present. 2,2 dimethyl. I said that the longest continuous chain was a 3, so that's going to be propane. And the endings you just have to turn off. So 2,2 dimethyl propane. Next, V. Okay, oh no, this is a different section actually now, but nonetheless we'll continue on. Name the oil refining process in which 1 molecule of alkane W was converted into 1 molecule of octane and 2 propene molecules. Now, that confused students to no end. Okay, so because they wouldn't have seen a question like this before, but they actually know the answer. Okay, so an oil refining process, there's 4 of them in total, guys. Okay, there's isomerization, there's dehydrosilylation, there's catalytic cracking, and then there's, oh, what's the other one there? Geez, I actually can't remember off the top of my head there what the adding oxidatives is one there as well. Okay, adding oxidatives. Okay, and you're asked to name the oil refining process in which a molecule of an alkane W is converted into 1 molecule of octane and 2 propene molecules. Now, only one of those involves making an alkene. Only one of those, and that's catalytic cracking. So our answer straight off there for the next one is going to be catalytic cracking. You didn't even need to see what W was. Okay, you just had to be aware that this is I again, I think. You just have to be aware that, what's the word I'm looking for, guys? That catalytic cracking involves breaking down a long chained carbon compound into shorter chained carbon compounds with an alkene always produced. In this case here, there was 2 alkenes always produced. Now, you're asked to deduce the formula of W. So W being here, so we have to figure out how many carbons was produced. Okay, so we had 1 molecule of octane and 2 propene molecules. So let's get started with that. Let's find out what's the molecular formula for octane. So octane is going to be C8 because 8 being oct, okay, and therefore the hydrogens are going to be 8 times 2 is 16 plus 2, okay, it's always the same, so it's going to be 18. And then propene, and there's 2 of them, so I'm going to just draw propene here. Again, if you don't know the naming of or the figuring out of the number of carbons and hydrogens, draw it out. Pro being 3, C3, H, and for all the alkenes, there's going to be twice as many hydrogens as there is carbons. So it's going to be C3H6. So here's C3H6. So all we're going to do now is we're going to add all of these up, and we're going to get, at the very end, we're going to get 8 plus 3 is 11, plus another 3 there is 14. So it's going to be C14. And then you will continue on with the hydrogens. So 18 plus 6 is 24, plus another 6 is 30. So it could be C14H30. And that's our answer there. And that was it. That's all you had to do. You just have to realize that, remember, like the conservation of mass states, matter cannot be created nor destroyed. Okay, so the products, the number of carbons and hydrogens had to equal the reactant that has been broken down with the catalyst of some kind. So W is C14H30. Okay guys, look, that was 2019. We're going to move on to the next one now. There will be a few parts to this, to these videos. Okay, so we'll do 2 each for each video, I think, maybe, depending on how long they take. So let's see, for 8 here, you're given octane is one compound found in naphtha in an oil refinery. It is converted to various other substances by processes A, B, and C. And we're asked then for part I to give the IUPAC names for the 4 hydrocarbon products shown above. Okay, now let's get started. Now, looking for the 4 hydrocarbon products, that means this is one product, this is another product, this is a product, and this is a product. Hydrogen gas here is not a hydrocarbon. Okay, it specifically said hydrocarbon there. Okay, so you're not to put this in. Okay, hydrocarbon is where it contains only hydrogen and carbon in its structure. Okay, there's no carbon here. So these are our 1, 2, 3, 4 products we have to name. So let's get started. We'll do. Look, we'll go down over here first. Okay, we'll do this guy over here first. We can see here that we have a benzene ring present. Okay, so as soon as you see that, you can put in benzene. Now, I'll write in benzene there actually altogether. Benzene. Obviously, there's a bit more to it than just benzene here. You've got a C2 group off it, C2H5. This is an alkyl group. Okay, methyl is CH3. Ethyl is C2H5. So the answer is going to be ethyl benzene. That's it. Okay, for the first one, ethyl benzene. Next, we'll go to this guy over here. So again, very similar to our naming structures for anything, we count out the longest continuous chain. So 1, 2, 3, 1, 2, 3, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So no matter what way we count it, okay, 5 is going to be the longest continuous chain. So that means the very end of it is going to be pentane. Ane, because there's no double bonds present. Now, there is, on the other hand, though, methyl groups. So all I'm going to do there is I'm going to assign numbers to them. And we want see how there's 2 methyl groups over here on the same carbon atom compared to the one over here. We want these 2 methyl groups to be the lowest number possible. So we count from left to right. So it becomes 1, 2, 3, 4, 5. So when we're naming it, it's going to be 2, 2. They're all methyl groups, so it's going to be 2, 2. And then 4, 2, 2, 4, trimethyl pentane. So our answer there is going to be 2, 2, 4, trimethyl pentane. Next, we have these ones over here. Now, this is obviously catalytic cracking because we're given two products. Okay, so that means some alarm bells will be going off there in which that one of these is going to be an alkene. Now, I strongly recommend that you draw out both of these just to make sure that you're getting it right. Okay, so I'm just going to the side here. You have plenty of paper, so there's no panic in drawing these out. So the first one there is CH3, so I'll take it CH3. Then there's a CH2. That means like this. Again, these just take practice doing. Then there's a CH. Grand. And then there's a CH2. Now we can see there's a problem here straight away. Okay, that this carbon and this carbon here do not have that's what I'm looking for. Do not have 4 single bonds, okay, or 4 bonds in total. So therefore, that's where our alkene is going to be. So if I put a double bond here, let's check it now. This carbon here has 1, 2, 3, 4, and this carbon here has 1, 2, 3, 4. Okay, so this is the alkene here, and if we're naming it, it's going to be 1, 2, 3, 4. So that means it's going to be butene. And then our last one has got to be our alkane, but we'll draw it nonetheless. So we have CH3 over there. So I put CH3. Then I have CH2 bracket 2. So that means there's going to be 2 repeating units of CH2. And finally I have a CH3 there. And this is an alkane. We can see here all of the carbon atoms have 4 bonds, and if we're counting that up, it's going to be butane. Now for butene, you could also call it, it doesn't matter, but-1-ene. It wasn't necessary in this case here, but just to let you know, you could put it as but-1-ene. That just signifies where the double bond is. But generally, if there's a 1, we never really put it in. It's like 1x. We don't put in 1x. We just leave it as x when we're doing algebra. So part 2 is to identify the processes B and C. Okay, well, we already said it for this one over here. There has to be catalytic cracking. So again, you have to specify which is which. Okay, so I'm just going to do B equals catalytic cracking. You'd be surprised how many students just write down catalytic cracking and they want it to be dehydrosilization without specifying whether it's B or C. And in that case, then you actually don't get the marks. Now, C has to be dehydrosilization because one, you're making a benzene ring, a cyclostructure, and the second one is you're getting rid of dehydro, you're getting rid of hydrogen gas here. Okay, so I can't spell this, so it doesn't matter. Close enough. So part 3 there is going to be the final part to this mini video. And what is this? Why are the processes A, B, and C carried out? Well, it's always the same. To increase the octane number. That's it. To increase the octane number, which makes the fuel more efficient, to prevent knocking, auto-ignition, and to increase the octane number. And there's a couple of ways we can do it. We can make them shorter, like so, like we have here. Okay, which increases the octane number. We can make them into a ring shape, which increases the octane number, benzene ring here. Or we can make them more branched, which also increases the octane number. Process A is isomerization, by the way, but we weren't asked for that. Okay guys, look, we went over 2 years there. My next video is going to go over another 2 years, and we'll keep going from there. You'll see that there will be a bit of repetition over the next coming videos, which is good. Okay, everybody, I hope that helped.